Okay, so proceed in we will proceed in various coordinate systems. So whatever we have done, that is a kind of many ways we pass through all the coordinate system. We will do interoperability among the coordinate system. Okay, so we have done each coordinate system. Either it is Cartesian coordinate system, polar coordinate system, cylindrical coordinate system, and a spherical coordinate system. We calculated surface area, we calculated volume. Volume we calculated through dual integral ways. One is taking the dV as a volume and doing the triple integration. Or we took a function fxy and did integration over an independent component, that is xy plane. So this is exemplary in a way that it is only available through us. So polar coordinate system, cylindrical coordinate system, spherical coordinate system, Cartesian coordinate system, everywhere we computed volume through dual ways. Otherwise, we calculated surface area of a sphere anyway. So we will see and we'll try to conclude interoperability. If I need to calculate the kind of surface area, if I need to calculate surface area, what is interoperability? Interoperability or hybrid model in coordinate system comes into the picture when we start our calculation through some way, and then at a moment we feel that we cannot continue. This is dual or this is hybrid model. Then if I have three parts in my computation of the integration, I have few parts, and a particular part I believe that I need to change it to another coordinate system. This part I need to change into another coordinate system. This is coordinate system interoperability or hybrid coordinate system. Calculus, you are amazing. Vector, you are amazing. Algebraic equation, you are amazing. Numeric science, you are amazing. Then coordinate system, you are also amazing. So now as we discussed that mathematics, we also tackle the way we tackle hardware system, we design the hardware layer by layer. The lowest level layer in the hardware means if I design an electronic circuit, then lowest layer in the electronic circuit, we make it as like it is completely error free. So if I am designing an electronic circuit, then what I would do is I'll go with the layer approach. The lowest level, the circuitry, the lowest level on which the higher level is dependent upon, on which higher level is dependent upon, on which higher level dependent upon. The lowest level is completely error free. In whatever the situation, if temperature is rising also, then it should take care. In any worst condition, it should work. That is the lowest level. And then we keep growing, means keep creating abstraction, and at the top, I get whatever I want. Similar way, the calculus starts with a numeric calculation, that is no way it is going to fall. 2 plus 2 will always be 4. On top of it, we see the algebra. Okay. Then on top of it, generally we see vector or calculus. Okay. Either vector or calculus or vector, and then on top of it, calculus or calculus, on top of it, vector, because calculus works on algebra. Calculus do not work on vector science or whatever. Calculus need algebra. So algebra, calculus, and vector. So I said vector and calculus parallel in the sense vector equation finally generates the algebraic equation. So numeric science, algebra, and two fork I can say. One is vector and one is calculus. So vector generates algebra and calculus works on algebra. On top of it, we have coordinate systems. So coordinate system actually gives the vector and then it can be transformed into the calculus, into the algebraic equation. What is the question? What is the question here? The query here is, or scenario rather, here is that if I have a set of algebraic equation and calculus or vector, whatever it is, a full set is there in one particular coordinate system, and then I am getting stuck. Or I believe that this part of this full equation, if this part, if I modify it to algebra, modify it to another coordinate system, then it would work very nice. Okay, so this way we go with the hybrid coordinate system. Hybrid coordinate system. Let's calculate the surface area of a sphere. Okay, so we keep telling that we want surface area of a sphere. We really have one sphere. So this is really a sphere. Okay. What is the surface area of a sphere? If this is a sphere, then what is the surface area of a sphere? So that is in question mark. Now, if this is centered, if this is centered at the origin, if this is centered at the origin, if it is centered at the origin, then if this is origin and this is surface, then at surface, if this is inside it, the center of this is the origin, then there is a point at the surface. If I draw a vector to the point, then that vector is nothing but position vector. Okay, so we are trying to calculate the surface area of a sphere. If that is the position vector, then what is the coordinate of the position vector? X, Y, and Z. That is the coordinate of a position vector. Okay, what is the position vector in terms of cylindrical coordinate? R theta, r theta, that is the arc, and r into theta, that is the arc, r theta, and then z. So if I start x-axis, then I mean r theta would move. So this much is the arc that it went. Okay, that is at theta and r, and then from there z. These are not available in any of the book. You can check it. So r, theta, and z. This is the coordinate of any position vector in cylindrical coordinate system. If we see the spherical coordinate system, then what it would be? There is no z. Okay, so there is no z. Or if I talk about z, then it will be r theta and a cos phi, that is the z. So r and theta, r theta and then z. Okay, so that is the what is the r and what is the theta, and then what is a r is any, r is any point, r theta, and then height is a cos phi. Cos phi is angle. If I, this is the P and this is the center, okay, P is at the touching the surface. If it is a center, then P and this is the phi angle. So P cos phi vertical P sine phi falls on the xy plane. So R I can replace with A, okay. So A is the full radius. So A sine phi. So A sine phi is the R, then theta, and then A cos phi. In cylindrical coordinate system, if we see, okay, if I see any point in cylindrical coordinate system, if I see surface point in the cylindrical coordinate, so if I am talking about a sphere in the cylindrical coordinate system, then certainly it will not be the surface of the cylindrical coordinate system. So in that case, it will be any r. So r, theta, and z. But if we talk in Cartesian coordinate system, it is xi plus yj plus zk. It is easy, right? Much easier than cylindrical coordinate system and spherical coordinate system. So if I talk about position vector of any point on the surface, then it is xi plus yj plus zk. What is the velocity vector of that position vector along x-axis? dp by dx. That is the velocity vector along x-axis for this position vector p xi plus yj plus zk. What is the velocity vector along y-axis for this position vector p? dp by dy. dp by dy, dp by dx, dp by dy, where p is a position vector xi plus yj plus zk, where p is a point on the surface. If these two are velocity vector, if I calculate cross product of it, it will give us the area. So dp by dx cross dp by dy would give the area. Area is velocity area. Velocity area vector, not simple area vector. Simple area vector means two vector, we will make cross product, it will give me simple vector area. But these two vector are partial derivative, they are velocity vector. So velocity vector, if I make cross product, it gives me area, velocity vector area. If I have velocity vector area, okay, this is velocity vector along x-axis. This is velocity vector along y-axis. If I turn it, then it is like this. If I make cross product of these two, then it gives me area. But this is velocity vector. This is not the displacement vector. If I make cross product, suddenly I get the area. This is rate of change in area because a velocity vector, meter per second. Okay. So if it is a velocity vector, the area vector what I am getting is the velocity area vector. Now, if I do integration of this velocity area vector, I get back the area. That is the concern. If I have a velocity vector, if I do integration, I get the displacement. If this is a velocity vector, I do the integration, I get back the displacement. If I do cross product of these two velocity vector, area velocity vector, if I do the integration, I get back the area. So that is the idea. But you will not get back the area, you have to compute the magnitude. We want algebra. Calculus eats algebra, calculus enjoys algebra, dependent upon algebra. So if I do cross product of two vectors, it will result in a vector 1, which will have direction that will be perpendicular. If I make a plane, then that will be perpendicular to the plane, but it will be a vector. If it is a vector, then calculus works on algebra. So I have to calculate the magnitude of the vector that will result in an algebraic equation, and that algebraic equation I have to now do integration. These explanations are not available anywhere else. Okay, so then everyone would talk that I want surface area. You are talking about two vectors and area that looks like a flat. we want we want curve surface area, curve, not velocity vector x and y and flat surface. Why you are worried? That's why layered approach is there. Layered approach means do your work and push up. That is the idea. So behind the scene, calculus and vector, behind the scene, there is something called algebra. Algebra takes care of the, since algebra is function over x and y, so at each x and y point on xy plane, there is a z value, fxy. That fxy would be such a different xy, it will compute a surface. Don't worry. That's the responsibility of algebra. This layered approach is not available in any of the book. This is we are introducing to make things simple, because at the end the target is to tackle the lion. Lion is artificial intelligence, neural network, deep learning, machine learning. So these are the lion. So we have to tackle that lion. To tackle that lion, we have to go with multivariable and this kind of layered concept. Otherwise, we cannot tackle. With simple calculus, the way it was coming along, it is not possible. That's why so many things we are doing. Vector, algebra, calculus, coordinate system, interoperability, and so many. If required, we'll create more hybrid model. Anyway, now if if I have area velocity vector, then if I calculate the integration, I get the, if I compute the magnitude, that becomes an algebraic equation. For that, if I compute integration, I get the area in algebraic equation 1, where it is a function of x and y. If it is like that, then keep changing x and y, you will start getting area from the beginning, from the origin. So if this is the beginning place, if you change x and y, because underneath origin is there, if you keep changing x and y, it will start area from there itself. So that is the concept of the kind of calculus. So calculus integration gives the algebraic equation only. If you have x, the integration is x square by 2. Again, algebra only. But x square by 2 is the net collection. If x is the velocity, then x square by 2 is the net collection. Keep changing x and you will get the collection from the beginning, or place the limit if you want the range. So here, if I have velocity area algebraic equation, if I do integration, then I get the area in algebraic equation. Keep changing x and y from the beginning, you will get the area. That is the concept. So if I have a position vector xi plus yj plus zk, then dp by dx is I plus dz by dx k, where z is fxy. So dfxy by dx k, dp by dy, position vector by dy, is j plus dz by dy k. If I do cross product of these two, then they would result in dz by dx minus dz by dx I minus dz by dy j plus k. If I calculate the magnitude, then it will be dz by dx whole square plus dz by dy whole square plus 1 square. This is the area velocity, velocity area. If I do integration of this, integration happens with only one component. So this is the equation of x and y, dz by dx whole square plus dz by dy whole square plus 1 square root. This is the algebraic equation, function over x and y. So if it is a function over x and y, then this algebraic equation would lead to a surface, because it is x and y, not only x. Otherwise, it will lead to a line. Here it will lead to a surface. If I am calculating the integration of a surface, then it is along the xy plane. Integration along xy plane, not along x-axis or y-axis, xy plane. So integration of algebraic equation square root of dz by dx whole square plus dz by dy whole square plus 1 square, and then we put integration sign, so d, that is xy plane, that, and one single integration, one point to other point in the area. So this is the net calculation for the calculating the surface area. Now if I have a surface, equation of the surface in 3D is z x square plus y square in for the sphere, x square plus y square plus z square equal to a square, that is the radius. That will turn up into z equal to a square root of a square minus x square minus y square. Now we will place here in the algebraic equation for which we are calculating the integration dz by dx whole square. So here it will come as minus x by dz by dx whole square. So dz by dx is minus x square root of a square minus x square minus y square. So dz by dx whole square plus dz by dy whole square plus 1 square root would come as the square root of x square divided by x a square minus x square minus y square plus y square divided by a square minus x square minus y square plus 1 whole square root. That would result in a divided by square root of a square minus x square minus y square, and then integration has to happen for the xy plane. So xy plane, now I feel it is difficult for me, that a by square root of a square minus x square minus y square, where x and y both are variable, then calculating the surface area along the xy plane is difficult for me. So what if one portion I convert into a polar coordinate, then it will be easy. This is interoperability. This is interoperability. Or I convert into polar or a spherical coordinate, then it will be easy. Then what is dA? Integration of this algebraic equation and then d of the xy plane. What is xy plane? If it is centered, if it is centered, if it is centered at the origin, if it is centered at the origin, then if I cut it here, equatorial, if I cut it at equatorial, then it will be, it is xy plane is nothing but a circle. Xy plane is nothing but a circle where radius is the radius of the sphere A. So if I calculating the actual integration is a by square root of a square minus x square minus y square. I proceeded in this fashion because it is easy to calculate the position vector doing the cross product and getting the Cartesian coordinate algebraic. That is easy, but after this it is sweating job. So then d of the xy plane is circle. If it is circle, I go with the polar coordinate or spherical coordinate, that is r d theta dr, that is the dA. D of area, surface area in xy plane is r d theta dr, nothing but r dr d theta. Here a by square root of a square minus x square minus y square. So if I have r and there is a theta angle between r and x axis, then x axis x is in a in a kind of a xy plane. If it is a polar coordinate, it's known that if it is a polar coordinate for a circle, it is x square plus y square equal to a square. This means that x I can keep a cos theta and y I can keep a sin theta, then this equation works well. If that is the case, then we are calculating r dr d theta, that is the dA. Now a by square root of a square minus x square minus y square. So a square minus x square minus y square. Now we have equation of the any circle is a square minus x, a square plus x square equal to a square. Now a is the full, a is the maximum radius. For any r, it is x square plus y square equal to r square. So x I can take r cos theta, and y I can take r sin theta, because if I am calculating the dA by square root of a square minus x square minus y square d a is the xy plane, dA I change into polar coordinate, that is r d theta, that is r dr. So r is any radius if I take, that is the case. So x now I change it to r cos theta, and y I change it to r sin theta. If that is the case, then it converts into a by a square root of a square minus r square, r dr d theta. So r a I can take it out, then r by square root of a square minus r square, r by square root of a square minus r square dr. Now this is interoperability. We started with Cartesian coordinate and surface dA. That surface we changed it into the kind of polar coordinate system. Now it is a, I take it out, r by square root of a square minus r square. The integration of this would be minus square root of a square minus r square, because if I do differentiation, it will come as r divided by square root of a square minus r square. So minus a square root of a square minus r square, that is the square root of a square minus r, that is the integration. Or now r starts from 0 and goes till a, that is the radius, that is the full radius of the sphere. Then this would lead to, if I keep a, then 0. If I keep 0, then it will be a. So minus will go off because 0 is down, lower limit. So a and a I had kept outside. So that is a square. A square d theta. So theta, if I take xy plane, then 2 pi. 2 pi a square. So 2 pi a square is the surface area of a sphere. Okay, but if you see the Cartesian coordinate system, we have now taken things from upper hemisphere. Okay, if we see the Cartesian coordinate system, then z, the a square minus x square, a square minus x square minus y square square root, z computation we had taken from the xy plane. So this all computation comes as hemisphere. Full, it is 4 pi a square. So it is 4 pi a square is the area of surface area of a sphere, but we started with Cartesian coordinate system, and then we ended up in the spherical or polar coordinate system. What can be other way? Okay, so spherical coordinates, this is more we took about the polar coordinate system. If we see the spherical coordinate system, then there is a three independent component. One is theta on the xy plane, another is r anywhere r. It's a sphere, right? Anywhere r, not on the xy plane. Anywhere r that goes from 0 to a, theta in xy plane goes to 0 to 2 pi, and from vertical there is another arc. Please refer previous video. So if from vertical, if there is an angle called phi, then it makes arc in the vertical plane. If there is a horizontal plane and there is an angle theta with r, then it's make an arc in the xy plane. One in the vertical plane, one in the xy plane, two arcs, and the radius. These are the three independent components in a spherical coordinate system. Now let's go back and what we had earlier. A by square root of a square minus x square minus y square, d of the area. What is the area in the xy plane? If we see a spherical coordinate system, then area in the xy plane is r d theta dr. So r is, if I take a as the full-fledged radius of the sphere and this is the phi angle, then a sine phi is the r, that is less than a at any phi, where when phi is variable. So r r d theta dr, r d theta dr. Okay, if that is the concept, then what is r d theta? R d theta is nothing but this arc. R is the radius along the x-axis, and then theta, r d theta. R is nothing but a sine phi. A sine phi, that is the r. A sine phi d theta. A sine phi d theta. And now dr. So r is a sine phi. If I do d of a sine phi, then it will become a cos phi d phi. So now we have r sine phi d theta, sorry, a sine phi d theta, a cos phi d phi. Now it converted into a square sine phi cos phi d theta d phi. Okay, that is the situation. Now go back, a by square root of a square minus x square minus y square. If that is the case, then in a spherical coordinate system, it is x square. If I see x square plus y square plus z square equal to a square, then in a spherical coordinate system, two angle comes into the picture, theta in xy plane and phi in the vertical plane. So if there is a phi and there is a, then z is a cos phi, whereas x is a sine phi cos theta, a sine phi sine theta. If I substitute in x square plus y square plus z square equal to a square, it fits well, where x is a sine phi cos theta and y is a sine phi sine theta. If I calculate this, it becomes a square plus sine square phi. Now, if I keep z as a cos phi, then a square sine square phi plus a square cos square phi, it becomes a square. So nice. So x is a sine phi cos theta and y is a sine phi sine theta. If that is the case, if that is the case, then we can now go ahead in Cartesian coordinate system. A by square root of a square minus x square minus y square. Now x I would keep a square minus a square sine square phi cos square theta, a square sine square phi sine square theta. That will turn into a square minus a square sine square phi cos square theta sine square theta become 1. Now a will come out and top a and bottom a cut out. So 1 by square root of 1 minus sine square phi, 1 by cos phi, 1 by cos phi. Now here we have a square sine phi cos phi d theta d phi. This is our version. It's not there anywhere else. So cos phi cut it down. A square sine phi d theta d phi. A square I can keep out, and now we have d theta sine phi d phi. Sine phi d phi d theta. Now sine phi, integration of the sine phi is minus cos phi. If it is minus cos phi, if it is minus cos phi, then I can take the phi from 0 to pi for full sphere, 0 to pi. Then it will result into 2 minus cos phi 0 to pi. Pi is minus 1 and 0 is 1, minus 1 minus 1 minus 2, and minus is outside, then it is 2. If it is 2 and a square is outside, 2a square. Now d theta, if I integrate d theta, theta 2 pi. So 4 pi a square is the full surface area of a sphere that we did from Cartesian coordinate into full-fledged spherical coordinate system, hybrid model. I started with Cartesian coordinate system because vector calculation is easy in xyz. But when integration came surface area, that is xy plane, I quickly changed it to converted into polar coordinate system, and then that is r d theta dr, and then we tried with the spherical coordinate system, that is r is a sine phi d theta, a sine phi d theta, and dr, d of r is r is a sine phi, d of r sine phi converted into r cos phi d phi. Now integration came into two independent components. One is theta and one is phi. Whereas in polar coordinate system, we had r d theta dr. So independent component were theta and r. Theta and r in polar coordinate system or cylindrical coordinate system are dr and d theta. So spherical, if I see Cartesian coordinate system, then it is dx dy, dx dy. Whereas here in a spherical coordinate system, it is theta and phi. This is what we took these two. Whereas in the polar coordinate are dr d theta. Can we solve it anyway? Means this is far easy. We started with something that we know very well, that is Cartesian coordinate system. Now, can we do surface area calculation along the x? I have already talked it about only in Cartesian coordinate system. If it is a by square root of a square minus x square minus y square, then the dA, the area is dx dy. If I want to calculate this, then a by square root of a square minus y square, that is a constant if I am calculating through dx minus x square. So x if I take as square root of a square minus y square cos theta. Okay, if I take this, then it turns out dx would be square root of a square minus y square minus sine theta d theta. Here a by square root of a square, this is our version, it is not anywhere else. So a by square root of a square minus x square minus y square would turn up into a by square root of a square minus y square minus x would become inside the bracket square root of x would become x square. So a square minus y square and then cos theta. So a square minus y square down, it is common. So square root of a square minus y square would come out. So a by divided by a square root of a square minus y square. Okay, and then square root of 1 minus cos square theta, that would 1 minus cos square 1 minus cos square theta. So 1 minus cos square theta would would be changed into sine theta. So sine theta, okay, I am not wrong, I believe. X I had taken square root of a square minus y square cos theta. So if I place it, then square root of a square minus y square would come out, and a square root of 1 minus cos square theta, that will result in sine theta. Sine theta. So now we have a by square root of a square minus y square sine theta. Okay, and now we have x equal to a square root of a square minus y square cos theta d theta. So dx equal to square root of a square minus y square minus sine theta d theta. So sine theta gone, square root of a square minus y square gone. Only thing remaining is minus a d theta. So d theta I will integrate over the full, then it will be 2 pi. So 2 pi a square, 2 pi, 2 pi a, 2 pi a, 2 pi a. So 2 pi and a. So 2 pi a is the net. Now we have dy. So dy minus a to a. dy is minus a to a, that is 2a. So 2a pi, 2a pi into 2a is 4 a square pi, 4 pi a square. So 4 pi a square is net the net kind of surface area. So we can calculate through Cartesian coordinate also. Same thing, I think we'll try again. We have already done, I believe, but we'll try again that doing the vector cross product as far as cylindrical coordinate system and spherical coordinate system. If we did all the vector operation here, then can we do directly the vector operation there rather than going for interoperability? So that we will see.